What's up guys, Shawnthebro here, and in today's episode of the Enhanced Input mini-series, we're going to be covering Enhanced Input in C++. It's going to be almost entirely C++. There's going to be a blueprint component just to link it to our character blueprint, but otherwise, we're going to basically go over what we went over in the first episode, but a little bit more advanced, setting them up in the code and then attaching them to blueprint characters to then use those controls that we set up in the code. Here is my Twitch game again. This is the game that we live streamed and made some progress on in a few of the other additional tutorials that I have. We're going to be using this one today. And in the series, I had movement working already for moving, jumping, attacking, all those good things. Now, I still have my other controls in here. I can still do them. I have overridden both the movement and the jumping to use the enhanced input system instead of the regular input action, input axis system. So even though everything still works together, we're actually using the new and improved enhanced input system for some of our basic functions that we weren't doing before. Also want to give a huge shout out to my YouTube membership and Patreon members and supporters. Thank you guys for requesting this topic and for all the support you've given me. I really appreciate it, and I'm excited to get working on this system so you guys can check it out and learn from it and start using it in your own games. If you want to get caught up in the enhanced input episodes, I'll link you to the previous episode, part 1 of Enhanced Input right here. And otherwise, if you like what you see on the screen with the side scroller in the form of a Castlevania style game, feel free to click this iCard right here in the top right corner. This will be the playlist for all of the live streams we did pertaining to this game. With all that out of the way, we can go ahead and get started. Let's get started by going into the code today. So we're not going to need too much to get this to work, but it is a lot more than your standard input actions and input axes. Once it is set up, you have a lot more freedom, but there's more groundwork to lay. We're either going to need a player controller or a character, and we're going to need the .build.cs file as well. So as far as my Twitch game character goes, I only have a character. I have not made a controller in here. So we're going to be doing this in the character class. If you're familiar with player controllers, it is very similar of how you can do it in the controller. We can get into player controllers and using enhanced input with them later in this little mini series on enhanced input. But for now, we're just going to put it in our character with the rest of our input actions and input axes. The first thing I want to go to is the Twitch game character.h, or basically your base character.h. In this class, I have 3 new variables that I've added. So specifically in the header file, I have added a variable for our input mapping context, as well as 2 input actions, one for an old input action, input to jump, and one for an old input access, input to move. The input mapping context is something we covered in the previous episode, and essentially it just tells the game or the character when this input is pressed at this time or in this context, what is it that we want to do? And so if you're playing the regular game and pressing that button causes a jump, you should jump. But if you're playing something like a mini game within the game and pressing that button does something like move an object, well then you should move an object when you're using the mini game mapping context. This is our default mapping context, so you can call it whatever you want. I literally called mine input mapping context, but you could call it default mapping context, basic mapping context, it doesn't matter. Also made it a U property of edit anywhere blueprint read write so that we can change it on the fly either here in the code or in the blueprint. And I've given it a category of enhanced input just so that we know we're dealing with enhanced input logic. So this is U input mapping context pointer input mapping context. Now below I have 2 U input actions, input to jump and input to move. The U input actions are also something we went over in the previous episode, but they are basically each individual action such as jump or move, or grab, or interact, whatever that action may be. These are also pointers, so you input action pointer, and then the name of your action. I've called them input to jump and input to move because I think it makes sense to call them that, but you can call them whatever you want. When you try to create this, you might get an error saying that you input action does not exist or can't find it. We have to actually add an include to access this class. So if we scroll up to the top of our .h file, we have to make sure we add this include inputAction.h. Make sure you put this above the generated.h include. Any includes you add always have to be above that generated include. So once you've added this, your variable type should work, and you should have 2 input actions, or really as many as you want. You can convert all your inputs to these input actions, or you can only convert a few if you only need the enhanced input logic on a few of your inputs. Regardless, I've made U properties for both of these, and they're the same as the context, so we can edit them anywhere. We can edit them in the blueprint or in the code, and we can give them a category of enhanced input, so all of our logic is in the same place. Now, after creating this, we also are going to need a function to call when these inputs are pressed. So just like any other regular binding, when a button is pressed, we call a corresponding function. I'm going to actually use my already existing jump function because the function you call doesn't really matter. If you're calling a function, the function itself handles the logic, so at that point we don't need enhanced input specific logic for any standard input actions. However, I am going to make a new function for the movement input action because it is a little bit different than our regular move right, move forward input axes that we had before in Unreal Engine 4 and before 5.1. I'm going to scroll up and I'm going to go to where my move right function is, or was. I have it commented out currently so that you know we're using the enhanced input and no remnants from the original move right function are here. We're not accidentally using that logic. Everything here is working from the enhanced input system. You don't have to comment yours out, but I do think it makes it easier to test, even if you plan on using it later. So I'd recommend just commenting it out. That way we don't have to worry about that. Instead, I've added a new function that I call enhanced input move. So void enhanced input move. And instead of taking in just a float value like move right did, enhanced input actually takes in an F input action value. So it's a little bit more advanced than just the float that your regular input system will give you. So just follow along with this because this isn't my specific logic. This is just anytime you are binding an input axis using enhanced input, you can use this const F input action value reference. That's what the ampersand is. And the parameter, you can change the name to be whatever you want. Typically, it is just called value in the old input axis system. So I just called it value here to make that comparison, but the name actually doesn't matter. The function name doesn't matter either. You can call this whatever you want. So you could actually just call it move right. I've just called it enhanced input move so that, again, we know what we're dealing with. Otherwise, I have my trigger jump and stop jump functions, which I was already calling before in the series. It's not really important. These functions actually aren't going to change. I just need some function to call when we have our input to jump input action pressed or triggered. And so just make sure you have any function available to call so you can test that out. At this point, we can go to our twitchgame.build.cs. And this is one we don't go into a lot. But we're actually going to need this to edit our enhanced input logic in the code. You can find this by going into the source file of your game. And in the source file, you have all your CPPs and your .h files. In here, there's also another one that is a C# file, and it should be the name of your game, .build.cs. When you open it up, it'll look very similar to this, if not exactly the same. Most likely, though, you will be missing this one tag in this section that says public dependency module names.addRange. So these are dependencies that we're adding and we can access, such as core, core UObject, engine, import core. You may have some others in here, you may not have all these, it depends on the version. But one we want to add is enhanced input. Just like this, it has to be exactly written out as I have it here. Doesn't have to be at the end of the list, it can be in any order, but it does have to be written out. No space between enhanced and input, and in quotes. Make sure you put a comma after the input core and plug it in here. The reason we do that is because that gives us access to some things we wouldn't normally have, and some errors we would get in the Twitch game character.cpp are going to be resolved by having this in here. So make sure you add this. Now we can go to our base character.cpp. And in here, we are going to scroll down to our setup player input component. This is where we had bound all of our functions to inputs before. Everything in here is going to be exactly the same, except I've also gone ahead and commented out the bind axis for the move right function. Remember, we're going to use the enhanced input for the move right, not the input axis, so I commented it out. You should also do this for jump at this point. So if you comment out your jump bindings, then we will be able to call the trigger jump function, but from the enhanced input component, not the regular player input component. You can technically have both, like you saw I did. Won't cause issues, but when you comment them out and then implement this new system, you'll see that it also works exactly the same, but now you have the freedom that enhanced input gives you. So comment out any old input actions or axes that you plan on using enhanced input for. Then you can go to where I have this comment that says enhanced input logic. And these are the 3 lines that I'm going to be adding today. So the first thing we need to do is actually get the enhanced input component. Now, the input component is what really knows what to bind actions to. So this player input component from the setup player input component binds actions of this name in the project settings to this type of input, so a press, to this object, and then calls this function when that input and input type has been met. And so instead of using the regular player input component, we want to use an enhanced input component. And to do that, it's very simple. The player input component can actually be cast to the enhanced input component, and then we'll just use our enhanced input component going forward. Now, this should work because in the previous episode of our enhanced input, I had changed our default classes for our input components to be enhanced input. But I am going to go back into my project settings. I'm going to type in enhanced. And then your default editor input class should be enhanced player input, not just player input. For your default player input class, you want to use enhanced player input, not just regular input. And for your default input component class, you want to use enhanced input component, not input component. The main ones we care about are these 2 that I set up in the previous episode. This one may be set up for you like it is here, but it's not always. It depends on your engine version. So I recommend just searching for enhanced and changing these, but you can also find them under engine input. And just to show you that, you can go down to engine and input and scroll down in this menu. And here are the default classes. Make sure you're using the enhanced version on both. I already am because, again, we set that up in the previous episode, but if you're not, just change them over now. That will make it so we can easily cast this player input component from being a regular input component to our enhanced input component. However, to actually access this variable type, we're going to also need to include this type in our base character.cpp. So my very last include here, include enhanced input /public / enhanced input component.h. That's where that file is that we need to access this type. Now we can scroll down back to where we were, and we can make a variable of this type. It is a pointer, just as the uInput component above it is. And you call it whatever you want. I just called it the enhanced input component. Then I casted the player input component that's passing the function to this type. That's all I'm doing here. I'm just saying if this input component can be an enhanced input component, succeed. And if it does succeed, we will then bind actions on it. If for any reason it fails, there's either something not set up correctly in the project settings, or for some reason the player input component might be null. So make sure you check for those things if you run into any trouble here. Now, after we get our enhanced input component, I know it's yelling at me with these red lines. This is just IntelliSense. You might get this. If you do, you don't have to worry. Just make sure you're building build solution between steps and making sure that the build is successful. If the build is successful, you don't have to worry about these red lines. Basically, something about Visual Studio doesn't understand what's going on, and it thinks that we're making some sort of mistake. So when we stop running the game, it is possible it will fix itself, or these may persist. But if they do, just build solution between steps here, and you'll see that the build will succeed, in which case we know we are good to go. You can see on my output log that the build has succeeded, none have failed. It's okay that one is skipped, that's the Unreal solution, which is not required to build every time. So at this point, even though I have these red squigglies, I am able to proceed. So now we want to bind our actions just like we would with the old input system, except using our new component that we have. So we have our enhanced input component, and we want to call bind action on it. Now, similar to the old system, instead of using the actual name of the input action, we're going to pass along the input action object. So instead of using jump in quotes like we did for the previous jump, we're actually going to use the input to jump that we made in the header file. Next, instead of just pressed or released, we have a lot more options for the trigger event. So press and release for the jump existed before, but now we have things like triggered and a few others. We covered these in the last episode of the enhanced input, so there's a lot of options here, and right now my IntelliSense is not working, so I can't actually bring them all up when I search like this, but you have a pretty long list. Triggered's the one we're going to use right now. There are plenty others you could use, and you can play around with them just by changing the event here off this enum. This is the same as before, so it's referring to this object reference. And then this is the function that we're going to call. So we're still going to call trigger jump like we were in the jump binding. But when we go to the move, it's going to be slightly different. So let's look at the next bind action. We're using input to move instead of input to jump. I'm still going to have triggered as the trigger event, and this for the object type. But then the function we're going to call is our new function. We're not going to call move right. We're going to call the enhanced input move. And the reason for that is we're going to change some things in our move function. So once you have this set up, you can scroll down. I've commented out the move function entirely. And that way, again, nothing with the move right is being used, and thus we can't get confused and wonder if we're doing the right thing with our enhanced input or not. Now, scrolling down to this new function, we have to make this. So make enhanced input move with the same parameters as in the header file. And before in the series, for the move right, we had some logic set up to basically rotate the character if we were moving a given direction, and otherwise we were just adding a movement input with the value that is passed in. Now the value that is passed in using enhanced input can be a lot of different things. It can be a boolean, a vector 1D, vector 2D, or vector 3D. So we need to make sure that we're using the right type and working with the right data. This is what I'm going to do for my side scroller example, but you have a lot of options. You can modify this to your liking. So feel free to get creative with it and make it fit your project. For me, I'm going to need a vector that we can move on, and to do that, I need an f vector 2D. Now, the way you get this is actually pretty simple, but I didn't know about it until you guys had shared it with me in the Discord. So thank you guys for all the assistance, everyone who helped out in the Discord for sharing this data with me. It was very helpful making this tutorial. So when we make our variable, we can actually use the value that is passed into the enhanced input function, called .get on it, and then put these angled brackets around the type that we want to obtain from it. So I know that I want an f vector 2D here, so I can actually do value.get f vector 2D and then parentheses after it. Const f vector 2D move vector equals the value that we obtain from here put into an f vector 2D type. The other thing we need is the rotation. It's not really important for the side scroller specifically, because if we are the side scroller, we just need our left and right. But I wanted to give you guys an enhanced input example. And again, everyone in Discord was very helpful with this. So I'm going to show you this anyway. Even though I don't really have a backward-forward direction, this is how you would implement it. So if you do in your game, such as a first-person shooter, a third-person adventure game, you'll have a forward, a back, and a left and a right. I only really care about the left and the right, but again, it's just an example. You can copy it or not. And so for the rotation, I make a constant f rotator, move rotation, and leave the x and the z axis as 0. The y axis, we use the controller's get controller rotation, yaw. Really what this is doing is just taking the rotation of the controller on the y axis and determining where it's at, how it's rotated. That way we know what our reference point is for our rotation. To be honest, it's not super important for the side scroller. I keep mentioning that because if you're doing a side scroller like me, it's not super important to know. All we really care about is left and right, but you may care about more in your game. From here, it's really simple. We actually are basically doing the same thing that we would do in our move right and our move forward functions. So I do a little trick that you don't have to do that allows for dead zone logic. So basically, I check to see if the movement in a given direction is above these small thresholds, and if it is, we can say, yes, we'll move there. Otherwise, we assume that the value is coming from, a little bit of drift or a little bit of movement that is not intentional, and so we don't move the character. On keyboard, you can't really tell the difference, but if you're using a gamepad or a controller with a joystick, you would be able to tell. Long story short, we have to grab the appropriate axis that we care about and check against a given value. So our move vector, which is obtained from the value parameter, has our x, y, and z, and the x component in this case is going to be the left or the right direction. So we make sure the move vector.x is greater than 0.05 or the move vector.x is less than negative 0.05. So we know we're pushing it farther than the dead zone, either to the left or to the right. And from here, what we can do is actually make a new vector by using a rotation vector and rotating it to a default static value, such as right vector or forward vector. You can see if I hover over this f vector : right vector, it gives us the value of 0, 1, 0. And when we were calling move right before, we were doing add movement input with an f vector and passing in a value only on the y-axis. We're basically mimicking that. This right vector has a 1 in the middle axis here instead of a negative 1. And so that is the axis that we care about in this case. And so now we can do add movement input with this right vector. That's something neat that you guys showed me as well. But otherwise, if you don't want to do this, you can actually copy this logic here. Instead of using this direction vector, you can use an f vector passing in 0, 1, and 0, and then you could get rid of this if you wanted. I thought it was pretty clean, so I'm more than happy to keep it. But just know that it's really the same thing as we were doing in the old move right, just a little bit neater and with a little bit more clarity on why exactly we're doing that. As for the value, we want to use our move vector.x because that's what we were checking here. Notice we were checking value is greater than 0, then using it. Well, here we're doing the same thing. We're checking to see if move vector.x is greater than 0.05 for the dead zone, and so I'm using that move vector.x. Now the forward and backward direction is essentially exactly the same, just we're going to use the y-axis instead of the x-axis. So I check to see if my move vector.y is greater than 0.05 or move vector.y is less than negative 0.05, just to know that we're not in that dead zone range. We're pushing it past it in one direction. And then here's the same deal as above. We're using this f vector direction vector. And really, we're just calling moveRotation.rotate vector and passing in this forward vector, which you can see puts a 1 on the x-axis instead of the y-axis. Again, not required. You could make an f vector, and you could put 1.0, 0.f, 0.f. That would also work. But make sure in the add movement input that we are calling move vector.y because we want to make sure that we're moving on the value that we were checking against. We don't want to move on x again now. Now we want to move on y. So we use add movement input just like we did above in the old move right function. Same function is being called, just with different parameters. At that point, that is our enhanced input move. My trigger jump is here, and it's the same as it was before, so feel free to use it if you want, but it's not required. This is just my original jump function. So now our enhanced input functions are set up, and they should be bound within our setup player input component function. Let's go ahead and launch the editor and take a look at what we need to do in there. Now we are back in the editor. I just want to show you that the move right and left and jump still work with the changes that we made in the episode. So I have my jump here, and I have my move right and left. That is move right fully commented out and the old jump logic commented out, and everything still works. So this is all using the enhanced input system. Now, if we go into a blueprints folder, and I have this folder called enhanced input, I had made a context as well as an enhanced jump in the previous episode in enhanced input part 1. It's not required that you watch that episode, although it would help, but I'll give a brief rundown of what's going on here. So we want to make sure that we have an input mapping context in the blueprint or an actual C++ class dedicated to it, because we have a variable, a pointer to one in our character class, but we need to actually have an input mapping context that holds the data that we're looking for. In the blueprint, it's pretty convenient. We can just go to add input mapping context, and this was the one that I created that I called character context. So in here, I had my enhanced jump, which was using up or gamepad D-pad up. So these were my controls. Now, everything in here is the same as the previous episode, but I'm going to open them up real quick. So my enhanced jump input mapping had up on the keyboard with a type of press. So basically, if we press the up key, we would jump. And we also had the gamepad, D-pad up, so we could use gamepad, and it was just a press was required there as well. If you want to add this because you don't have it from the previous episode, you simply can add a new mapping, which adds an action mapping. From here, you can select the action mapping that you want to use. In my case, and for today's episode, I'm just adding enhanced move, but add as many as you want, or if you're following along directly, add your enhanced jump and your enhanced move. When you click the drop down, only input actions that you've created should show up. So if you haven't created an input action yet, nothing will show up. That's okay. Let's create one now so that we can continue along with the process. If you already have an enhanced jump from the other episode, you don't need this. But here is my enhanced jump. I have a description here, just says handles jump, that consumes inputs and can trigger when paused. It is also a Boolean type, since it does not need to be a vector for any reason. So basically it just knows if we pressed it or released it. To make an input action in the blueprint, for the same reason that we had to make a context in the blueprint, we will go to add input and input action. Now we want to make one anyway because we want to make one for the enhanced move. So again, make as many as you need. I need one at least for my jump and one for my move. If I go to my move, it's very simple. This is how I've set it up. I have no description, but I can add one. Handles movement. I have it to consume input. That is fine because this just means if there is another event and this has a higher priority, it will consume it. So it will only listen to this one. That's perfectly fine. We don't need to mess with that. I do want to trigger when paused in case I want to use my left and right or up and down movement on the pause menu. I don't have to reverse all mappings. This is for inversion or rotated worlds, not required. My value type I put as a vector 2D because that's what we're using in the code. We're getting an F vector 2D. And so we want to make sure that our movement can handle an F vector 2D. I don't put any triggers or modifiers in here as default as I'm going to handle them in the context mapping. Now going back to my character context, you should definitely be able to add a mapping now. And when you do, you'll be able to select one of your types. So let's do enhanced move. Once you have your input actions in here, you can press the plus here to add your individual bindings. So I've added an A and a D for left and right. Another thing you guys taught me is that you can actually use modifiers to change the direction. So I have A and I have D. I've selected both my keys here, so literally the A key and the D key. The triggers are what has to happen, such as the press, the release, any of those specific actions. I don't have any of them set up because we just have triggered in the setup player input component. And so basically if any of these actions happened, if we did anything at all, it will trigger. So just if the button is pressed, it will trigger. That's really enough in this case. But you could of course do more like I showed in the previous episode. But for the modifiers, I have A as negated because otherwise both A and D are going to return the same value. So D is to my right, which is my positive value in this case. So I want D to be positive so I don't have to do anything else with it. But A is to my left, which is the negative value in my case. So if I negate it, it actually inverts the value. So it's basically like using a negative one instead of a positive one. So thanks for that tip on the modifiers. So now I have my input actions set up in my context. The next thing we have to do is go into our character blueprint. And I have a paladin character BP, but you can go to a base character BP or whatever you have. In here, remember we set up the blueprint, read, write, and edit anywhere, so we can actually search for enhanced input, which is our category. And put the space in there like I have. And so now I can assign these. So I want my input mapping context to be my character context, my input to jump to be my enhanced jump, and my input to move to be my enhanced move. You can select them by simply clicking the drop downs, and only relevant items should show up. Now once you do this, you should see that they start working. You can actually use them in the game, and your movement should be fully functional. However, if you did follow the previous episode, we had this enhanced input action, enhanced jump blueprint event. We're not going to want that anymore because we're doing it in code. I mean, if you want to keep it for any reason, by all means, but we don't want it to consume input over our other code ones. So you should be able to take it out at this point, compile and save your character blueprint. And now you should still be able to jump. Everything should still work, but we're going to make sure that it works without the blueprint event so that you know the code event is working, and you can see that it is. So anyway, guys, that's all I got for you today, so thank you so much for watching. I hope you enjoyed and learned a lot about enhanced input. It's very, very useful and very fun, and we're going to be going into even deeper methods of control and controller management with it in the future. If this helped you, and you want to help me, then feel free to subscribe. It does more for myself and the channel than anything else you can do, and I really appreciate it. I want to give a huge shout out again to my YouTube membership and Patreon members. Thanks again for all the help for this episode and helping me learn enhanced input with you guys. It's a lot of fun. If you had any questions about this tutorial or any problems that you ran into, feel free to join the Discord community. There's a link in the description. Otherwise, guys, that is all I got for you, so thank you so much for watching. I am Shawnthebro, and I'll see you in the next one. Goodbye, guys.